Okay, so today what we're going to do, okay, guys, we are going to identify polynomials. So we're going to learn what a polynomial is, categorize them, like what kinds of polynomials we have. We're going to multiply monomials with monomials, binomials, and trinomials. All new words. Well, maybe not new words, but for the most part might be. There is a little brain buster activity, but see if you can expand the page and don't cheat. Look at the answers on there, unfortunately. I have mine with a screen. So if you go to the next page, it's about the paintballs. We had a crazy weekend of paintball. You guys ever play paintball?
Yeah,
I don't like it. Anyway, four friends. Paintball. Four friends were having great fun. The paint came in blue, green, yellow, and red. Coincidentally, the four friends had T-shirts in the same colors. So, can you list what color paintballs each person used and what color T-shirt they were wearing? It has nothing to do with polynomials. It's just a fun little problem. So, well, some might be the same color. Here's the list of what I know. Can you figure out who's wearing what? But don't look at the answers. So make the page big so you only see the questions.
Oh.
The answers are at the bottom of the page. Sorry about that. Anyway, how would you go about this? I would make a chart. You've got Brenda. And we have the shirts, the shirt color, and we have the paint color. This is how I would do this. Person in the green T-shirt used yellow paint. Well, guess what? I don't know who that is. James, I have, was not wearing a red T-shirt. Diane used green paintballs and wore a blue one. So Diane has a blue shirt and green paint, right? And then Brenda used blue.
Wait, Brenda, who said Brenda used blue?
That's I'm putting in my chart. Simon was the only person who used paint which was the same color as his T-shirt. Well, that's the question. Well, why is it red? Because the person in the green T-shirt used yellow. So the only color left is red.
Well, what if James and you guys oh!
He has the same color, and because we've accounted for all the other colors, we can't use that. So then, let's see. James, I don't know, right? James is probably the one in the green T-shirt with yellow. Whoops, yeah, that's right. And so Brenda has to have what? Yellow, right? A yellow shirt. Okay, so all I did was make a table. And did I get that right? Simon had red and red. Brenda had yellow, blue. And the rest should follow. Okay, it's just kind of a fun little problem. Not a big deal. Because today's lesson is not that long.
Why would they all wear different?
It's just a math problem.
I don't.
It's not even, it's a logic problem. But let's get into what we're going to talk about today. We're going to talk about polynomials. Now, polynomials are important when you do more math later on, and many of you will go all the way through pre-calc or through finite, MST. You're going to have to know what a polynomial is. And polynomials are nice because they behave nicely. Okay, when you graph a polynomial, are you stuck? Yeah, they should be in the right place. When you graph a polynomial, it's always a nice, smooth curve. There are no corners. There are no breaks in the graph. There's no holes. It just is nice and smooth. That's all it does. Is your iPad not working? Oh, okay. So, we need to know what this is. And I can ask you 4 years from now what this is, and you probably won't be able to tell me. Okay, we're going to be doing, see that stuff up on the board there? We're going to be doing that this week, multiplying binomials. A polynomial, poly means many. Okay? It means many terms. Actually, it means any number of terms. Okay. You can have more than one variable. You can have x's and y's and z's in there. Okay, Joey? Okay, here's one of the conditions. You can only have adding, subtracting, and multiplication, which means no division by a variable. So you can't have 1 over x squared. That's dividing by a variable. Okay, Jay? So we can't do that in a polynomial. And the exponent must be a positive whole number. Actually, that's redundant. It just has to be a whole number. You guys know what whole numbers are? Okay, they're not fractions. What else are they not? They're not decimals. Can they be negative? And no negatives. No. If I wanted to list whole numbers, they would start with 0, 1, 2, 3. They're whole. There are no little parts to them. There are no negatives. They're not integers. Okay, India? Let's set off. Because there's a lot of talking here. Okay, so polynomial has many terms, and terms are separated by adding, subtracting signs. So we haven't even talked about what terms are. So which ones of these are polynomials? Tell me why, or tell me why not.
Because the other one, wait,
Okay, let's look at this one. Let's do one at a time. Let's go in order. Is this a polynomial? Why not? Because the exponent is a fraction. Now, you can have fractions. You can have fractions in front. You can do 5/3 of x cubed. That's okay. The only thing that's not okay is having the variable in the denominator. Okay, and I know this isn't particularly exciting, but it's really necessary. How about this one? That's a polynomial. Okay, Jack? Because the exponent, what is the exponent? No, that says 3 times x, that's a 1. Because how many x's do you see? 1. Joey. Because all the things that we do in our lives is we like to model situations with mathematical formulas. That's how they build bridges. And if I can use a polynomial, because there are no breaks in the graph, all the more reason that you use polynomials. Anyway, there's going to be, you want to model situations, okay, and there are no breaks in the graph, and they're nice smooth curves. You do not want something that has a break in the graph or has a sharp corner. Those are much harder to work with. When you get into calculus, polynomials are easy. The other things that have sharp corners are not easy in calculus. So that's the problem. But that's what I want to do. I want to use this for modeling, depending on whatever you want to look at. The exponents cannot be a fraction. Well, there's nothing to do with it. Right, you just say no, it's not a polynomial. So this is a yes. What's wrong with, or is there something wrong with the third one? Let me rewrite this, because I don't like the way that's written. It's 7 divided by x plus 10. What's wrong with that one? It's not a polynomial because I have a variable in the denominator. Can't have that. That would be a negative exponent. We haven't done exponents yet. Okay, what about 5? Yeah, that's fine. Now, there is an exponent here. How many x's do you see? None. So that's x to the 0. I don't know if you knew that. X to the 0 is just 1. Let me write that down. There aren't any x's there. Make sense? Okay. Now, when we do our polynomials, we count how many terms there are. Okay, India? Terms are separated by adding and subtracting signs. Term. Separated by plus and minus signs. That's how you know how many terms you have. It's something added to something else. So when I look at this example on the blackboard, it's an x squared plus 2x plus 1. These all count separate because of the plus signs. How many terms do you see here? Right here on the blackboard. I don't have it on the whiteboard.
Yeah,
3. 1, 2, 3. And those are the polynomials we're going to be working with. Okay, so you guys, a monomial, mono means 1. Yes? That's a whole number. That's okay. It's the exponent that can't be. The exponent is what can't be a fraction, a decimal, or a negative number. The exponent. This is the exponent, the 5 here. And, well, we'll talk about what it means in a second. And the x is the base. These are all monomials. There's only one term for each one of these. How many of you ride bicycles? Well, for any reason. You ride a bike? Yeah. How many wheels are there? 2. So a binomial has 2 terms. Okay, now, how do you count the terms? It's not the timesing. It is the adding and subtracting. So this has 2 terms in it. The 3x and the negative 4x to the 5th. Then, this one has 2 terms. The terms are separated by these plus or minus signs. So there's 1, there's 2. 1, 2. And before you wrote, well, they're not together unless if I put a plus sign between them, then I have 4 terms. And there is no special name for that. The only ones we have special names for are the monomial, the binomial, and before you rode a bicycle, many of you rode a tricycle. How many wheels were there? 3.
I never thought of tricycle.
A tricycle? You might have had training wheels. Yeah. A tricycle? It's got 3 wheels. Okay? So a tri means 3 terms. What are the terms in this one? Careful. The terms, okay, Joey? The terms in the first one is a 3x. That's the first term. What's the second term? Careful. What's the second term? There's the first one. Negative 4x to the 5th. The term is all of that together. Okay, Matt? Jack? What's the third term? 8. Okay. More vocabulary. Doing this is not terribly hard, but it's not that easy, but we'll see. Okay. Do you understand what terms are and how to name these? The ones that are important are the monomials, the binomials, and the trinomials. You could have 37 terms. You could have a lot of terms. We don't have special names for those, though. Okay. Quick check. Is that a polynomial? It's a binomial because there are 2 terms. Everything's okay. My exponents are whole numbers. How many x's do you see here? You see 1. Okay, go to the next page. You ready? Look at it carefully.
That's a non-monomial.
Why?
But that's decimal.
Because the exponent has a decimal.
We call it a non-monomial.
I suppose you can. I'm going to call it not a polynomial. Because we can't have decimals in the exponent. You can have it in the problem. The exponents must be whole numbers. How about that one? Jack, how about that one? Hey, a monomial. Okay? Are we feeling more comfortable about the names?
I feel so comfortable. Oh,
Good. How about that one, Jane?
second.
How many terms?
Let's try.
Good. 2. 3. Trinomial. There you go. Check the exponent, because even sometimes I mess up if I don't look at the exponents. It's the number of terms. Terms are separated by the plus and minus signs. So there's 3. This is the first term, this is the second term, and that's the last term, the third. So you look for the pluses, not the times. Okay, new word, maybe a new word. This comes from the Latin word, Matt, coefficio. I don't know if you've seen this word before. Coefficient. Coefficio, the Latin word, means to come before. So, a coefficient is the constant. We have to fix this, by the way. It's not right. Okay, India? Numbers aren't attached to terms. They're multiplied. So cross out attached and put in multiplied. Terms are separated by adding and subtracting. Coefficients are the numbers that multiply the variable. So you're going to have to keep that straight in your head. So if I'm looking at 7x, what's multiplying the x? 7. So it's the multiplication. So when I look at this, negative 2x cubed, let me slide this up. So it's negative 2 times x cubed. If I wanted a plus there, I have to see the plus. I don't see a plus. So what's the coefficient? What's the number that's multiplying x cubed? Negative 2. That's the coefficient. It's a number. We're going to get to the leading coefficients shortly. That's next. The coefficient is the number you multiply the variable by. 3 is the exponent, and x is the base. That's the number you're multiplying by itself. Now, the 3 does not operate on the negative 2. Not unless I do this. Then it does. But it's not in parentheses. So the exponent only works on the letter it's next to unless it's outside of parentheses. Which means do everything in that parentheses 3 times. It's coming in the future when we'll do more of that. Polynomials, that's all you ever use in calc. We try to model every situation, and in terms of science classes, we want a polynomial because they behave nicely. That's the reason. Okay, leading coefficient, Jesse. Another word, leading coefficient. Okay, here's the deal. The leading coefficient is the coefficient of the term here. By the way, how many terms are in this? Oh, let's look at the first one. 8x, 5x cubed. Sorry, let's look at the first one. How many terms are there? 3. It's the number that precedes the one with the highest exponent. And generally speaking, why they call it a leading coefficient is we don't write our polynomials like this. We always put our highest exponent first. So if I wanted to reorder that, because I can, what is the highest one here? So it's 5x to the third. Then the next one would be plus 8x minus 6. This is the leading coefficient because that's the leading term. It's the number that's multiplied by the variable with the highest exponent. And when I say the highest exponent, we call that the degree. So this is a third degree polynomial. And hopefully we don't get higher than 3 because things get complicated and the numbers get bigger. So far all you've done are linear, like x plus 3. The exponent here is 1. Those are okay. I know how to graph those. That, not so much. Well, I do. It's going to kind of wave around like this. Okay, so let's put this in the right order, the second example, and then it'll be easy to find the leading coefficient. So which is the first one? I've got how many terms here? 1, 2, 3, 4. Right. So which is the first one, Nick? Which one's got the highest exponent? X to the what? Look at your exponents. That's 1. There isn't any here. That's 4, and that's 10. Which one's the biggest exponent? Yeah, this one. So it's going to be negative 12x to the 10th. Then what's going to come next? Cross that one out. What's the next biggest exponent? 7x to the 4th. What's next? Plus 10x. And there's only one left, minus 4. So we always go highest to smallest. What's the leading coefficient then? Maddie, what's the leading coefficient? Negative 12. Can I just write it this way? That'll see.
Oh.
Leading coefficient. Okay, so we had a lot of words. Which is not exactly fun. But the problem with math is it is a language and you have to know the vocabulary. Next year in geometry, there's many, many more words. If you want to go to most colleges in this country, you must have geometry. Well, maybe come back with me next year. Okay. Okay. How do you multiply two monomials? Okay, Matt. I don't think I'm going too slow. I think it takes some thinking here. Now, we have to know what to do with exponents. What does x squared mean? It means x times x. So if I don't know what to do with the exponents, I'm going to write out what it means, and then I'm not going to forget. Okay, Cole? So I'm going to write this out. It's easy. It's so easy, though, that you can get confused. So 3 squared is 3 times 3, right? Now, exponents is just a short way of writing out repeated multiplication. 3 cubed is what? 3 times 3 times 3, and if I count up how many 3's are multiplied, how many are there? Nick? 1, 2, 3, 4, 5. Yes, because the same add the same bases, and that's what you do. You just add the exponents because that's what it means. Yes. I don't know.
Maybe all 5.
I think they're supposed to put the exponent there, but I didn't like it, so I put it here. Okay. Now, some of you want to say that this is going to be 4 squared. Write out what it means. I have 1 4 here, times, and then I have 4 times 4. How many 4's are there? 3. So some of you like to ignore the exponent that's with the 4, but it's there. You just add the exponents. 1 plus 2 gives you 3. Another way to look at it is, how many 4's do you see here? It doesn't say it, but I see 1. No, I see 1. I see 2 there. So I'm going to have a total of 3. So what's this going to give you for the last one? 8. And that's going to fit in the little box. Those other boxes didn't fit. So how do you do these? You just add the exponents. And that's what the rule is. If you have the same base, add the exponents. So, if I have 3 squared times 4 to the 5th, can I do anything with that? I can't, because that means 3 times 3, 4 to the 5th means 4 multiplied times itself 5 times. I can't simplify that. They're not the same. What if I have x squared plus x cubed? Can I add those? No, they're not the same. It's not multiplying. What about x squared times x cubed? That's x to the 5th. These are okay, but you can't do anything with x squared plus x cubed. They look a lot alike, but they're not exactly alike. They got to be exactly alike. Okay, so some of you are going to get all mixed up with that. So let's do some problems. Oh, these are easy. I hope. Yeah. You have 7, and you add 2 more to it, you get 9. That's what an exponent means. It's how many times was x multiplied together. When in doubt, write out what it means, and you'll be fine. You just count. That's why you add. Yes. This one? Well, how many x's are here? There's 1 here, and you're going to multiply by 4 more. So you just add the exponents, which is x to the... Yeah. It can't be x to the 4th if you think about it. If it's x to the 4th, that would just be that. You have another x multiplying there. It's got to have to go up. It can't be 4. It doesn't make sense to be 4. Okay? Now we're getting a little harder. Just a little bit harder. Now, this means 4 times x, and then this is 2 times, and I've got 4 x's multiplied together. Remember, an exponent is repeated multiplication. I know how to do the 4 times 2. Order doesn't matter when I multiply. 4 times 2, 2 times 4. It's the same thing. Okay, girls?
Wait.
I just wrote out what it meant. So what are you going to do with the 4 and 2? Because I can't. Just multiply them. So 4 times 2 is 8. This is not distributive property. And then I have 2 x's and 4 more x's, so it's x to the 6. So you have 2 things happening here. You have these coefficients being multiplied, and that's why I like you to know the vocab. I don't have to say the numbers multiplying by the x's. That's too much. It's a coefficient. You add the exponents and you multiply. When you divide, you subtract, but we aren't dividing, so we're okay. Yeah, let's do that one. You ready? Let's multiply these together first. What's a negative 3 times 10? Negative 30. Now, I know some of you want to say it's x to the 6th, but that's x to the 6th. You still have another one. How many x's are there multiplied? There's 6 here, 1 more. It's 7. And the answers are online, so you can check your work. You should easily get this done today. Okay. Now, what we have to do is I see distributive property. You see the difference between this problem here and this one here. This has a plus in it. Yes, we're going to get there. Distributive property, and you really need the whole thing. Distributive property of, you're going to combine multiplying with addition or subtraction. It's multiplication over addition. There's no adding in that one. You can't distribute. It's not distributive property in this top one. This is. So the 3x gets multiplied times everything in the parentheses. So I'm going to take 3x times the x. What's that going to give me? That's 3x squared. Girls, is that okay? And everybody in the last class, is about everybody, forgot to distribute. These are mailboxes. Every mailbox here has to get multiplied by 3x. What's 3x times 2? 6 what? Can you add those now? No, they're not the same. X squared and x are not the same. It's like having an iPhone 5S and an iPhone 4S. They look an awful lot alike, but they're not the same. The 5S, you can lock your phone by using a fingerprint. Can't do that on the 4S. Okay, so there are differences. Minor, but they're not the same. So if I'm taking inventory, I'm going to sell the 5S for more than I sell the 4S because it's brand new. So you can't equate them. So let's try this next one. And this one's in here twice, so we don't need to do it twice. So we're going to multiply these together. So first I multiply the coefficients. So we're going to multiply negative 5 times 2. What's that going to give me? Negative 10. And actually this turns out to be the easier part, I think, for you guys. Jay, what about the x's? I have x squared times x to the 4th. So I'll have x to the what? Good. Okay, Nick? And then I have to multiply this times this one. Now, be careful. I got to do a -5 times a -5 plus, and 5 times 5 is not 10, that's plus. I'm multiplying. It's 25, and then it's x. I've got 2 here. One more makes a total of 3. You see how I'm counting it? Yeah, that's all there is. This is not a long assignment. Even though there's like only 20 minutes left, you should walk out of here with your assignment done. Let's try a couple more. And we'll walk around. We got 2 more problems to try, and maybe somebody wants to come up and put this up here. Yeah, skip the second one. Maybe somebody wants to go put their answers up there. We'll come around and check things. Yeah, it does. Here. It works. There, you gotta get it in right. There it goes. It does charge slow. My iPad charger was stolen last year. So, I don't know, I just use a regular phone charger. Okay, so you should try the first one and show me what you get. I don't know. Let me see what you got. Yeah, that's right. Oh, I like the colors. Yeah, where's your work, kiddo? No, on that. Yeah, you want to write your answer up? Why not? Okay, guys, you haven't done the problems. Do the problems. You're so skinny. Huh? No, but you need to do them.
Okay, so I went to the festival.
Doing these, so do them. I'm going out to check. Paul, where's yours? Let me see. Oh, it's X cubed. Right, your X. Don't forget the X's. That's another thing I've seen. Yes. No, it's nice. It's, yeah. You want to put your answer up? Oh, right here. Okay, you should get this answer for this third problem. First, really, it's the second problem. And if you don't get it, you need to ask. Long doesn't do the trick. Done easily. ask you to expand it. In other words, multiply it out. You're right. Expanded form is not the right word. When Jane comes back.
Oh, but you don't know.
Okay, any questions on this one? India? Okay. Yep. So you should get CDA for the top ones. For number 4, you should get x squared. CDA. Yep.